Welcome students to another session of practicals of class 12. The initial portion can be used by class 10 students as well. The aim of our experiment is to determine the angle of minimum deviation for a given prism by plotting a graph between angle of incidence and angle of deviation. Now, let me give some introduction. We have two apparatus. You might have seen this is a glass slab, and as you can see, the speciality of the glass slab is both the edges are parallel to each other. This is a pair of parallel edges, this is parallel edges. So, and when we are going to a prism, both are made up of glass, you can say, and here in a prism, this is a rectangular prism because here you can see the base is rectangular, here rectangle, and this is the prism part. So in this prism, what happens is you can see that the surfaces are not parallel, they are inclined at an angle. So the property of the light ray which enters a prism will be different from that which enters through a slab. Okay, so here I will show you. I have drawn here slab here, outline you can see, and I have drawn prism you can see here. So I am keeping both the things. Now let us observe with the help of a laser light that when I keep the incident ray, this is my incident ray, this is the normal. Similarly for this I have drawn an incident ray and the normal. Okay, so when I put the laser in the incident ray here in the slab, what you can see is incident ray of the laser, and this is the ray emergent ray. You can see here a line. See, this is the emergent ray. Okay. Yes, here is the emergent ray you can see. Now coming to the, but the emergent ray as you can see is parallel to the incident ray. Now here when I come to the prism, you can see one thing that instead of going there, it is diverting here. Just you see, it is getting diverted along the line of my pencil. You can see here, it is getting diverted in another phase. This phase, I am putting light from this phase and it is getting diverted in this phase. That means the property of the prism which you can see is, if there is a straight line going here, and you can see this is a straight line, okay, straight laser. Now if I keep this prism in the path of the straight line, okay, so the straight light is incident on this phase, and you can see that the light is after moving inside gets deviated in this phase. Now see, I am moving this. It is again moving in a straight line. Now the path is deviated. You can see that the path is deviated. I keep it like this, the path is deviated. I keep it like this, the path is deviated. Okay, I think you have followed this small concept that when I keep a slab, since the edges are parallel to each other, the ray, this is the incident ray, this is the emergent ray. You can see the incident ray when extended is parallel to the emergent ray, just because the two sides are parallel to each other. And in this, since the angles are at 60 degree, there are three phases, you see this to be deviated. Okay. So now coming to the main aim of our experiment, And the aim of the experiment is to determine angle of the minimum deviation. Okay. So for class 10 student, I would like to tell, this is for 12th also, I'll just tell you how to make up with it. So first of all, I have taken this prism, and mind it that don't put this is the rectangular face and this is the prism. Okay, so what I am doing is I am drawing a line here. So what are the things you can see I need is, for this experiment, these are protractor, scale, these are the pins I have some colored. This is the pencil and rubber I am having. Now I will draw with pen, but I am asking you everyone to draw with a pencil and using a rubber, because you are required to do with a pencil only, but since you will not be able to see properly, so I am doing with pen. So here I have put the boundary of the prism here. Now moving a bit from the center, I have put a point here. Now from this point I am keeping this protractor and drawing the normal here. So this is the normal end. Now how to take the angle of incidence? Okay, so from here, on this normal, I am putting this D in this form. Here I have. Now this is the normal. So from here I have to take the angle. Suppose I want to take it to be, suppose 40 degree. Okay. So 0, 10, 20, 30 and 40. So I have taken it 40 degree. So now you have to draw a straight line here. So this is angle of incidence. Now what I am doing is I am extending with the dotted lines this angle of incidence. Now suppose I would have taken this normal this side, then it would have been extended this way. So I wanted it to be extended here. So first of all I put an arrow here to show that this is the incident ray. This is angle I 40 degree. Now I want to find the angle of deviation. So for this I will put the prism here. This is a trick I am going to say you. So now I have taken, you remember angle of incidence is equal to 40 degree. So now you can see this is only a trick. You need not to do with this method. You are supposed to do with this pin method. I will teach you that pin method also. Now what I am doing is I am putting a laser. ये थोड़ी tricky है, trick method है. This is the drawing board, by the way. I forgot to tell you. This is a soft wooden board called the drawing board. To fix the paper on this, I have used this pin. Now you can see that here you are getting a it's a trick. You have to practice for this, okay? So here I am putting the incident ray. Now you will get a ray here. Just watch carefully. You will get a ray here, which is the deviated ray. Yes, here you get a deviated ray. You can see. You can see the deviated ray. So I have taken 2 points on this deviated ray. Okay? See? 2 points on the deviated ray. Now what I am doing is I am connecting these 2 points, extending it inside and connecting it with the extended incident ray. This is the emergent ray. So now this angle is the angle of deviation, del or D. So angle of deviation is defined as the angle between the extended incident ray and extrapolated, यानी पीछे आगे बढ़ाना, extrapolated emergent ray. देखिए emergent ray इसलिए मैंने एरो बाहर की तरफ लगाया, तो एंगल डेल है. तो 40 डिग्री के लिए कितना डेल हुआ है ये मैं आपको अभी बताती हूँ. So I have done it for you, class 10th student. So you can see that this is for both 10th and 12th. You can see this is the initiation I have done. So I have kept it done. This is angle I 40 degree. This is angle del, that is 38 degree. Now since this prism is a equilateral prism, so every angle is 60 degree. Okay, so one formula you can apply here, that is I plus E is equal to A plus del. For every prism this will be correct. Now I means angle of incidence, which is 40 degree here. Now emergence angle I have to calculate from here. So angle of the prism is 60 degree and delta, that is angle of deviation, is 38 degree. So this is 98 degree. So this also should be 98 degree. Okay. So now for calculating the angle of deviation, the point where it touches, here I draw a normal with the help of D. Here I am doing with a pen. And now this angle between the normal and the emergent ray. Okay, so this is angle of emergence, which I will measure and it will come out, let me see, 58 degree. So 8 or 9, 98 degree. So this should come true for every set of practicals. Okay. So now this class 12 student, class 10 student, only this much you have to do. Okay. Now further extension for class 12 students I will try to do, because here I have to take different I and different del I will get. Okay. So let us be prepared for class 12, that is to determine the angle of minima. Class 10th only one you need to do and you have to paste it in your practical notebook. Now the main experiment, we have taken this wooden box, soft wooden board, which is also called drawing board in the physics lab. To fix the paper, I have used these thumb pins. On the four sides you can use it. Now as you can see here, you have to take the angle of incidence 30, 35, 40, 45, 50 and 55. So I suggest you to do all the 6 experiments in a single piece of paper. I am doing with pen so that you can see it clearly, but you need to do with pencil. Please don't take photocopy and paste in your notebook. You do it yourself. Okay. So here I am putting a line, straight line, and here I am putting another straight line. Now here I will draw 3 boundaries here, for which this is for 30 degree, this is for 35, this is for 40, this is for 45, this is for 50, and this is for 55 degree. Okay. Now I will take some points here away from the center in the left hand side, and with the help of D, here I will draw the normals. Okay, for every case I will draw the normals. Now with this I will put the D. See how I am putting the D. Please don't put the D this way. This is a wrong way. You have to put the D like this, and you have to take the reading, that is the angle of incidence, from this side. So here it is 0. Inner one you have to take 0, 10, 20, 30. So here you got 30. So what you are going to do is, you are taking this 30, and from here the dotted lines are coming. This is normal and arrow you have to put to show this is angle of incidence when I is equal to 30 degree. Now, as I told you that trick, you can put the prism here and you can trace the line here. But the actual way is, first you trace it, the trick you play, and then you do the actual method. An actual method is you have to put 2 pins over here and then put the prism, and in that line which you get here, you have to see through this face of the prism by bringing your face on the surface of this prism, and 2 more pins you have to put here such that these 4 pins, when seen from this face, lies on the same straight line. Then that line you have to connect to this. Remember, it will meet inside. Okay? So I have prepared something for you. So I'll show you that one with one exemplar. Okay? As you can see that I've drawn the outline 30 degree, and here I have got the angle of deviation. So what I am doing is I am keeping the prism, and as I told you, I will use a trick, that is the laser trick, and then I will use the pin, the actual method. Okay, so here you can see very nicely. You can see very nicely. You have to set your, देखो. See here. See here the line is coming. दिख रहा है? इस फेस पे दिख रहा है. ये देखिए. उस लाइन पे मैंने 2 पॉइंट्स बना लिए. ठीक है? Now, okay. बस. Now, what I am doing is, वो जो 2 पॉइंट्स बनाए ना बेटा, उसमें मैंने 2 पिंस पुट अप कर लिए. And then I will put 2 more pins here. Actually, these 2 pins are supposed to be done by me by looking into it from its face. But I am doing a trick, a shortcut. Now, I'll show you using the camera from here that all the pins are in the same straight line. See, can you see? All the 4 pins are in the same straight line. See, those 2 pins in the back, these 2 pins in the front, and as I move, see here, see students, all the 4 pins, देखो पीछे वाले pin अब नहीं दिख रहे हैं. ये चारों pin, they are all in the same straight line. Okay, so now what I do is I pick up this and यहाँ पर ये गोले बना लिए जहाँ पिंस थे, यहाँ जहाँ पिन थे वहाँ गोले बना लिए, and now ये वाला लाइन जोड़ लिया. This angle of deviation is 50 degree. एंड यहाँ पर जहाँ ये एमर्जेंट रे एक्स्ट्रापोलेटेड टच हो रहा है वहां पर एक नॉर्मल बनाया, एंड दिस इज एंगल ऑफ एमर्जेंस, एंड हियर I plus E is equal to A plus del. You can see. Now for 30 degree, for 35, 40, 45, 50, 55, I have done this. You see it very carefully. Now I will show you the readings which I have got. That is angle of incidence 30 के लिए इतना, 35 के लिए. So here you can you see this is continuously increasing, but here this is decreasing 50, 39, 32. That is, this is the minimum deviation. 40 में minimum deviation delta minimum is 32. Then again as this increases, this also starts increasing. So now if I plot a graph of this I versus delta, then I get this. I, angle of incidence, this is angle of deviation. You have to plot, this is your aim, to plot the graph. Now this is I versus del. This is the minimum deviation. Freehand curve you have to draw. कोई point अगर छूट जाए तो कोई दिक्कत नहीं. So this is del, that is minimum deviation you can see. And scale I have taken here 10, 20, 30, 40. Here also 10, 20, 30, 40 I could take because I had a big graph sheet. And I have written the scale here. So in this way I have determined the angle of minimum deviation of this prism. Now you may have a query. You may have a query that on what factors does this depend? Angle of deviation. Why I am saying minimum deviation? The factors on which angle of deviation depends are angle of incidence. You can see as I am changing the angle of incidence, deviation is changing. Material of the prism. That is, glass is of also different materials. So depending upon the material of the prism, angle of the prism, and color of the wavelength of light used. Here I have used light. You have seen green laser I have used. So depending on that also, but generally I use white light. That means जब हम pin method करते हैं तो sunlight use करते हैं, white light use करते हैं. So in that case you can do this. Okay, I hope it is very clear to all of you. You have to do this, and personally you have to do this and paste this graph as well as this paper in your notebook. Thank you.